Welcome back. Time for the third video of section one of unit one. This is section 4.3. So we're going to take a look at ratios and proportions. A ratio for us is just a comparison, one thing to another thing, maybe how many Doritos I eat to how many Doritos you eat, how many dollars I spend on Phillies merch compared to how many dollars you spend on Phillies merch. Generally, you relate one thing to another. You will probably not relate feet to pounds. If you say, well, I've got a ratio, I can write it as a fraction. I can write it with colon form, and you might recognize both of those from previous instructions. If we decide that two ratios are equal to each other, we basically have built a proportion. And my guess is if you go back to somewhere in the middle school grades, somebody told you that it's really easy if you just cross multiply and you can set about solving proportions. I should probably tell you as a finicky math instructor that's really akin to what we saw in the first video for this unit, where you're multiplying both sides by a common denominator kind of idea to wipe out both fractions. But good news for us, the notion of cross multiplying works quite well. And that's what you see represented on this screen, where if we multiplied one diagonal, we would get A times D. If we multiply the other diagonal, we get B times C. And we're just basically going to say that's what we got. That's the result of cross multiplying to solve this proportion. Have a good day. So first example is a cheese puff. You're simply going to get 2 times 2.5 on one diagonal and 5 times x on the other. Doesn't really matter which you write on the left versus which you write on the right. I opted to go with 2 times 2.5. But if you would rather have gone 5x equals, that's perfectly just as fine. Multiplying by 2 gets us to 5 is equal to 5x. A quick divide, and that baby's out of here. So first solution, not much going on, just a notion of multiplying on a diagonal and making that equal to the product in the other diagonal. A little tougher in that you're going to have a distributive property, but again, if that makes you dive under the desk, it's probably going to be a long semester. So 3 times the quantity x plus 10 is identically equal to 7 times 9. There's your distributive. Let's subtract 30. Let's divide by 3. Oh yeah, x at 11. So a couple of just straight outs and you just solve. A lot of times proportions walk into the midst of word problems. So the good news is here we found Packer fans at Immaculata. So as a Packer fan, I feel home. I feel kinship. The problem says there are 3 Packer fans for every 200 students, and the student population is given at 2,400. So there's the lovely little proportion for us. 3 is to 200 as x. How many is to 2,400? And a cross multiply gets us going on. And there's 200x on the right side, 3 times 2,400. Calculator if you wish. Good news is we found 36 Packers fans. All right. Certainly crazy units, zipnids and whacknoids. All you've got to be careful here is when you build your proportions, you want to make sure that you're consistent with where you're locating things. So if you write that first fraction, so you're going to put 8 on top and 15 on the bottom, because that's the way you met the numbers in the problem, that's fine. You've put zipnids on top, you put whacknoids on the bottom. Be consistent as you build the right side fraction as well. So I said, hey, that sounds good. Let's put 8 over 15. Make sure you realize that on the right-hand side, then the 96 represents a zipnids number, and it's going to be the numerator player on that. X is on the bottom. And if you go ahead and cross multiply, which I didn't go ahead and solve here because I figured the rest of the step by step you probably have mastered at this point in time, you would realize that if we traded in all 96 zipnids, we could get 180 whacknoids. All right. And again, you've kind of already heard this in a previous discussion. When you're creating the proportion, you have some flexibility. You just have to be consistent. So whatever quantity you're indicating on the numerator of your left side fraction, you want that comparable quantity indicated on the numerator of the right side fraction. All right, so for the last problem, we put zipnids on top in both cases. But if you're feeling particularly rebellious, you could have put whacknoids on top as long as you had been consistent and put them on top of both fractions. Good news. That ends the discussion for Unit 1. So as I said way back when, most of what you saw in this unit should have been in review. So this will conclude our first learning activity for this unit. I'm going to set up what will be your first learning lab, and I called it cleverly Activity 2 for Unit number 1. And you'll notice it's a series of problems from your textbook. Right? You'll notice when you look at the material in in the Moodle shell, there'll be an activity unit 2 or an activity 2 for unit 1. And these number of problems will be listed for you to do and submit. As I grade them, I take a look for your approaches and hopefully get lots of good answers and you get lots of clean points. If you have questions on these things, if things are starting to cause stress, you got to contact your instructor. Shoot me an email. We'll try to get a chance to sit down and we can go over some content for you. This wraps up video 3 for Unit 1. Check back later for the video series from Unit 2. See ya.